Hello all, welcome to the thesis presentation. I am Ravi Ramchandran. Today I will defend my thesis on hateful content detection in social media using large language models, including persona and policy-based techniques. This research was completed as a part of the MS in Machine Learning and Artificial Intelligence program from LJMU under the supervision of Dr. Dattatreya Parle. In today's agenda, I will guide you through the motivation behind the thesis and the main research objectives and the key findings from the study. We will start by discussing why hate speech detection on social media is such a critical challenge and what gaps exist in the current approaches using the literature review. Next, I will outline the specific goals of this research and how it aims to integrate the various techniques into large language models. Post that, we will spend some time on the implementation, primarily on the dataset unification and the actual implementation which is available on GitHub. Finally, we will preview the major results, including the accuracy and the fairness, and set the stage for a deeper exploration of automated hate detection. By the end of the session, I hope to give you all a clear understanding of both the technical innovations and the practical impact of this work. Before we start, let us spend some time on hate speech. Social media platforms have become central for global communication, and they also have uh, an all-pervasive problem, which which is amplifying the spread of hate speech. The sheer volume of posts, especially hundreds and millions of daily on platforms like X, formerly Twitter, makes manual moderation impossible. There is an article by Woolacott in the Forbes magazine, which talks about a staggering 1,662% percent increase in hate speech against Asian minorities. Primarily, the anonymity and the global reach of social media allows malicious users to spread slurs and coded bigotry, and therefore it becomes very essential for us to develop robust tools which can assist human moderators and protect vulnerable communities. Detecting hate speech is not just about finding explicit slurs. Much of today's hate speech is coded or indirect. For example, research by El Sharif in 2023 shows that most systems miss subtle forms of hate speech. Hatred against different groups often relies on a small set of stereotypical words, but these words can be used in both positive as well as negative connotations. This makes disambiguation very difficult. There are lexical detection methods available, but they rely on word lists, which tend to have low precision and often misclassify offensive language as hate speech. There is a study by Davidson in 2017 which found that supervised learning approaches struggle to distinguish between hate speech and general offensive content. These challenges highlight the need for more sophisticated detection, which can understand context and nuance better. In this section, I want to highlight the key limitation of existing hate speech detection models, which we will cover in more detail in the literature review. Primarily, this fall in the context of rule-based systems and machine learning classifiers. And the biggest problem about these approaches is they struggle to capture subtle patterns and context. This leads to large number of false positives, meaning a lot of hate speech goes undetected. Pilot experiments on anti-Semitic speech showed that accuracy was very high at 94%, but recall was just 60%. This low recall limits the effectiveness of these systems because they missed a significant portion of harmful content. Deep learning models are also available. The study by Yin and uh, by Yin et al. Showed that they often act like black boxes, which makes their decisions difficult to explain. The lack of transparency is a major concern for building trust and ensuring fairness. Overall, these challenges underscore the need for more advanced and context aware approaches that can reliably distinguish between hate speech, general offensive languages, and provide explainable bias aware moderation. There have been newer approaches which have uh, already been tried out. Primarily, these fall into persona and policy based approaches. We will first define what are persona approaches before we discuss the various literature and the techniques available. Persona methods primarily enrich classifiers with user-centric features like personality traits, demographics, and behavioral patterns. and improve fairness in handling ambiguous cases. The persona methods, however, raise the concern about privacy, demographic profiling, and potential bias, especially when the user data is sparse. Policy approaches primarily anchor moderation to formal platform rules using multitask learning or policy as a prompt strategies. But policies struggle with evolving language and rigidity of the predefined rules, and they potentially also miss the nuance of emergent forms of hate speech. Now, with the advent of large language models, newer opportunities have come in where challenges such as persona sensitive biases or inconsistent moderation guidelines can then be resolved. Needless to say, addressing these issues is crucial for developing effective and trustworthy hate speech detection systems. Uh, the literature review was done for hate speech detection, and this shows the timeline of how hate speech detection methods have evolved over the past decade. From 2012 to 2025, traditional approaches which relied on rule-based systems and classical machine learning was used. The primary strength of these methods was they were very good at catching explicit hate speech like direct slurs, but they struggled with subtlety and context-dependent language because they use static lexicons and pattern matching. They also missed a lot of implicit hate speech, resulting high false negatives and limited adaptability. Since 2021, policy-based methods, NLP methods have become very prominent. These methods are aligned with formal platform rules and moderation policies and use multitask learnings. These have improved consistency and coverage, making moderation decisions more in line with platform standards. But they still struggle with evolving language and the rigidity of predefined rules, and sometimes miss nuance. Between 2023 and 2025, persona-based NLP methods have gained traction. By incorporating user-centric features like personality traits, demographics, these models have improved the nuance and fairness of hate speech classification, especially in ambiguous cases. The concern about privacy, as we discussed earlier, still persists, especially if the data is sparse. Overall, the field is moving from rule-based systems to more sophisticated models that consider both speaker and platform policies. The latest trend since 2024-25 is to integrate multiple signals for more robust and fair solutions to hate speech detection. These hybrid models that combine both persona and policy methods address the limitations of each approach when run in isolation. And early studies had found that these signals improve the accuracy and the fairness. Um, we will first go through each literature for starting with traditional hate speech detection. This slide talks about the traditional hate speech detection methods and how they have evolved and where key gaps persist. As a summary, early rule-based systems and classical ML approaches such as the paper by Warner, Hirschberg, and Davidson, they rely on manual lexicons and pattern matching and bag of words. They perform relatively well on explicit insults, but consistently miscoded or context-dependent hate, yielding low recall, and false positives, especially on benign profanity. Wasim Hovey in 2016 showed the sensitivity to sarcasm and language drift, especially when especially when single annotators are present and there is a single annotator bias that persists. More recent work experienced with data augmentation and specialized architectures. For example, Penzel used GPT-2 to boost recaller F1 using for SVMs. Though noisy synthetic noise was a concern there. Zhao in 2021 tried out sentiment informed by LSTM and multitask setups, but they remain fragile to sarcasm and contextual hate. So dataset and centric efforts were also tried out. Piot had something called meta hate, which sought to unify benchmarks, but they still expose annotation inconsistencies and label imbalance. This reminds us that metrics can vary widely by category and harmonization may be obscure. Harmonization may obscure like a lot of dataset nuances. Primarily, traditional methods, there are three key takeaways. Traditional pipelines detect overt hate but falter on implicit contextual hate. Data quality is a concern, so is annotation fairness. and advances that integrate context and target awareness and fairness controls. There is a potential for LLM assistance in them to achieve robust, trustworthy moderation at scale. We move towards policy methods, which were started post the persona methods. Zhao et al. Used BiLSTM for multitask sentiment knowledge sharing, which improved context awareness, but it still struggled with sarcasm. Greco deployed a Robota-based system with human in the loop, but found domain specificity and reliance on predefined categories limited the adaptability or the generalization of that model. The recent study by Singh, this was done at IIT and was multilingual, shows that diverse multilingual data and rich pre-training was crucial for robust policy directions. But as with all LLMs, there was a need for large number of resources. So the primary gaps for policy methods were context, domain adaptation, and policy encoding, which highlight the need for future systems to combine flexible language understanding with explicit policy alignment for a trustworthy moderation. Persona methods, which were introduced later, use models like BERT and LLMs to incorporate user traits and demographics. Lee and Ram showed and Raut and Spazano as well showed that adding persona features can improve fairness and nuance. But there were risky privacy issues. There was a lot of data bias if the user data was incomplete or inaccurate. Yuan Gajakeswa highlighted the power of persona prompts, but also they showed that this can introduce bias and struggle with readability and manipulation. Overall, if you look at persona-based models, they offer promise for more context-aware moderation, but ethical risks and robust unbiased performance always seem to be a challenge. Recent advances in hate speech, as we discussed earlier, was on policy and persona signals. There are two papers and techniques that we are discussing here. The first one by Roy, who used GPT 3.5 and FLAN for explicit persona and rational prompts to classify hate. The result shows that LLM struggle with implicit hate unless given clear cues about what target group. So prompt techniques were found to be really important. Piot applied debiased tuning to llama family and then fine-tuned them so predictions remain consistent. This helped address cultural bias, but and supported global policy standards. But selecting which attributes to debias, so attribute selection, remained a challenge. As this field emerges, the literature there is significant scope for research in uh, incorporating multiple techniques for debiasing and developing far more better, fair, and explainable AI systems, which is the focus and the gap that is identified in our research. So, elaborating on the research gap. So, the key research gap is that there is no technique that fully integrates persona and policy methods in a unified framework. Though persona methods are known to improve nuance and reduce bias, but risk inconsistency, and policy methods are known to enforce standards, but they may miss context. There has been no standard way to evaluate systems for both fairness and accuracy using a combination of both these techniques. There have been some recent works, as we pointed in the previous slide, to combine both of these techniques, but they lack a general LLM solution which can explain the decisions of using both those policies together and what are the right ways to integrate them. So addressing these gaps is the focus of this research, uh, which which I have defined further in this problem statement. The main goal is to bring together both persona and policy-based techniques instead of one or the other, and address the challenge in a more holistic manner. There is no standard for LLM, especially when we look at the more recent models like GPT OSS 20B and GPT-5. These combined techniques have not been systematically applied to this task. The proposed solution is to design and validate a novel LLM driven system that merges both of these techniques and try it out in both open source, which is basically the GPT OSS models, and commercial models like GPT-5, and see whether we can create a robust, fair, and context sensitive hate speech detection. We will elaborate on the goals for based on this approach in the next slide. This slide talks about the primary aims and objectives of this research. We aim to create a empirically validated unified large language model framework for automated hate speech detection. And this framework is unique in the sense that integrates both policy and persona signals. And we are going to focus specifically on three personas in the context of this research, especially the LGBTQ, Mexican, and the Middle East personas. By leveraging open source models like GPT-OSS and commercial models like GPT-5. The aim of the study is to systematically compare the multiple model configurations, including the various prompt setups, as well as supervised fine-tuning using LoRa. A key part of the methodology is also to use the balanced benchmark datasets like hate explained oxygen, and then create a unified dataset which can then be used for further research, along with the findings, and to improve on the current methodologies. The research also involves designing a modular evaluation framework that supports prompt engineering and parameter efficient fine tuning to enable robust benchmarking. We are going to evaluate performance using metrics like accuracy, precision, recall, as well as fairness indicators like false positive and false negative rates. The main aim is to analyze the quantitative impact of persona based and policy based and hybrid strategies on bias and fairness. And ultimately, the goal is to provide actionable recommendations for ethical and scalable AI speech detection. The comprehensive approach has been designed with the main goal to maximize the effectiveness and trustworthiness of hate speech detection systems. We will double click on the research methodology. As we discussed earlier, we want to develop and validate a unified LLM framework for hate speech detection. For that, what we have first done, and we discussed the findings as well. We conducted a comprehensive literature review to identify whether these gaps really exist. These gaps do exist, so that helps us understand the limitations of the current methods, and that is the motivation for us to propose this integrated solution. Then we will prepare like an integrated benchmark data set with hate explained oxygen, which will focus on key personas given the time limitations of this study, especially the LGBTQ, Mexican, and the Middle East personas. These datasets will then be unified to ensure fair representation and robust evaluation. We will design a modular evaluation framework, and this modular evaluation framework will use parameter efficient techniques like LoRa as well as instruction fine tuning using different kind of combined persona and policy prompts, and we will systematically benchmark these on multiple LLM architectures, primarily GPT-5, GPT-OS 20B, and GPT-OSS 120B. With a systematic comparison of the five key model setups, which is primarily GPT-OSS 20B, 120B, and GPT-5 for prompt engineering, and GPT-OSS 20B for supervised fine-tuning. We will evaluate them using metrics such as accuracy, precision, recall, F1 score, and fairness indicators. And based on this, the goal of the entire methodology is to provide actionable recommendations for hate speech detections using this methodology, which will be effective as well as fair for various diverse user groups. Uh, we will the next slide. We are going to talk about the research implementation, primarily from the perspective of the dataset creation. For this particular research, in order to combine both policy and persona signals, we are using a combination of hate explained dataset and as well as Toxygen datasets. Toxygen datasets have around 250K entries, and hate explained has got 90 around 20K entries. And hate explained is specialized on primarily of multi multi-annotator or multi-persona offense, whereas Toxogen is focused on benign or hate, which is basically implicit. We will merge both of these data sets and maintain an even ratio between Toxogen and hate explain. And by merging both of these data sets, we will get a unique data set which will combine the strength of both, which will support nuanced persona aware detection as well as which will support policy evaluation. And that is the base on which we will perform all our experiments. For the purpose of this experimentation, we will also create like a reusable framework. The implementation centers around two core components. One is prompt engineering and supervised fine tuning. We'll create a reusable prompt suite for systematic benchmarking of the large language models by providing baseline persona based and policy constrained instruction templates. So baseline as well as combined. So we will call these templates as combined templates, which are basically combination of both persona and policy constrained instruction templates. We will test them across architectures of GPT-OSS and GPT-5 using the prompt validation framework. For the prompt validation framework will support like a multi-run benchmarking and robust error handling, and this is one of the frameworks which we will be sharing out uh, as a reusable framework for further research on these areas. For supervised fine tuning, we will create like a SFT framework which will support QLoRa with 4-bit quantization and do its accelerator framework for multi efficient training on multi GPU systems. Together, this entire framework will establish a scalable and reproducible methodology for developing hate detection systems. This entire framework is available on GitHub. Um, at this particular location. I will just go over the overall folder structure for the same. This a large part of this is self-explanatory. The entire data in the unified data set is available in the data folder. The data collection automates the download of hate explain and oxygen sources. The data preparation folder contains the pipeline to normalize the schema as well as unify them and export them into the unified data set. The model adaptation is managed by the fine tuning folder where QLoRa training with multi-GPU support is implemented. The prompt engineering pipelines are available in the prompt engineering slash pipelines folder, and it's a multi-threaded framework for testing and validating the various prompt strategies, including baseline, persona, policy, and the combined strategies. The raw and process data sets are stored in the data folder, and the tests are available in the test folder. This entire framework can then be downloaded or cloned in JIT and run in the choice of ID using Python. The requirements, the dependent libraries are mentioned in the requirements.txt. So this completes the entire implementation approach, which is which is used as a part as a core of the research methodology. Post this implementation, the results were collated and published. We will go over the results in the next few slides. The entire validation methodology was split into two phases. First is basically run the various techniques for hyperparameter optimization in terms of in terms of like prompt engineering and instruction fine tuning. This basically is different prompt designs which are there. And post that, the best prompt was then taken and then validated on a larger data set, which was common across both the IFT and the SFT. For the GPT-OSS 120B baseline experimentation, the baseline standard configuration emerged as the best. It achieved a F1 score of 0.626, and when run on a full data set, it achieved a F1 score of 0.615. So there's only like a 1.1% drop in F1 scores. The bias analysis revealed that the group disparities. So the LGBTQ plus group had the highest false positive rate at around 43%, and Mexican Latino had around 8.1%. So there was quite some amount of bias, especially for LGBTQ, and this highlights the importance for bias-aware optimizations, especially for large-scale data sets, which is closer to what is there in the real world. The same baseline experiment was tried out with different GPT-5 prompting techniques. The GPT-5 achieved the best balance of accuracy and fairness, which was around F1 of 0.528. And however, the point to be noticed is recall dropped quite a lot, especially like almost close to 0.464 or 46.4%. So at scale, GPT-5 or model became very conservative. Bias analysis also showed that all protected groups had elevated false negative rates, with the Middle Eastern group for GPT-5 having the highest at like around 56.8%. So these results highlight that while the model was very precise, the risk of under-detecting hate speech, especially for certain groups, was very high when we used the GPT-5 model with the baseline prompts. This requires further tuning for recall and fairness, which we will do when we integrate persona as well as policy signals as using the combined prompts. So next, combined prompts were tried on the GPT OSS models. Primarily in this phase, we tried out 21 prompt engineering strategies which we tested, and only a top 5 are shown here. The basic result was that of all the strategies that were tried, the compressed demonstration based, which is basically example based prompts, which were tried in version 5, specifically the chain of thought and implicit examples, outperformed the baseline score from baseline GPT OSS, which was 0.615. And there was the scores reached close to 0.654 and 655 for implicit examples. The other point to be noted is recall also improved to 0.70. So there was greater sensitivity to hate speech when persona and policy signals were integrated. Um, and the earlier the more verbose approach as a contrast performed worse, which F1 scores dropping. So overall, the analysis showed that prompt compression and implicit examples uh, prove critical for robust fair detection, and also detection improves when both policy and persona signals are integrated uh, in GPT-OSS. Combined prompts. So next we move to combined prompts for GPT-5. The GPT-5 combined prompts achieved the highest accuracy and precision among all the tested approaches, but the recall was dropped quite a lot to 0.568, resulting in a lower F1 score of 0.607. This indicates that the model became more conservative, favoring fewer less positives when policy and persona signals were integrated. Bias analysis also showed exceptional precision, especially if you look at Mexican and Middle Eastern groups. The false negative rates are elevated. So overall, as compared to plain vanilla prompts on GPT-5, the combined prompts which integrate policy and persona signals with few short examples improved the specificity as well as the cross-group fairness, which validates our hypothesis. But more fine-tuning is required, which should be taken up as the next steps for further progressing the study. If we compare all the results across IFT, GPT-OSS and GPT-5 showed clear benefits from prompt compression, noise reduction, and the use of implicit examples. V5 implicit examples and chain of thought, implicit examples as mentioned over here, uh, achieved the highest F1 scores of 0.655 and 0.654, and recall of 0.701 and 708. GPT-5's combined prompt demonstrated stronger generalization and better balance between precision and recall at production scale, make it robust for real world deployment. So, in effect, the hypothesis of adding both persona and policy signals is validated. At the same time, what was also found is that fairness remains a challenge for both models, especially for the LGBTQ group, where error rates were consistently higher across all the examples. GPT-OS's top strategies reduced missed hate speech, but increased false positives, while GPT-5 achieved like exceptional precision in that area. And um, the technique that has worked across both the models is primarily like prompt compression and implicit examples, and they're critical for optimal performance. So compressed prompts and demonstration based prompts are outperforming a lot of other techniques that we tried, like verbose alternatives. um, the primary recommendation, especially for IFT, is to go for GPT OSS is the primary model for deployment due to its superior accuracy and recall, while constant monitoring needs to be done to remove bias. Next, we tried uh, supervised fine tuning using QLoRa on GPT OSS, using both combined, using training using combined prompts. Primarily, we tested three configurations, out of which the testing methodology followed was pretty much what we did for IFT, with a smaller prototype and a larger evaluation. And the high capacity setup for which was tried in phase 2 gave the best results, close to 0.669, outperforming even the best combined GPT versus model, which had basically an F1 score of 0.655. The improvement in recall. So when we look at the recall, the improvement in recall shows that the model detects more hate speech, though precision has dropped slightly. So recall has increased at the cost of precision. The other interesting finding was when combined signals were applied, the fairness analysis showed substantial gains, especially across Mexican and Latino groups, Mexican and Middle Eastern groups, with lower false negative rates, um, with and balanced precision. The concern still has been LGBTQ as in IFT, which has remained elevated. So there is a fairness challenge which is there. But overall, when we look at it as compared to IFT, SFT with LoRa has increased targeted hate detection significantly. It has boosted sensitivity and equity in hate speech detection, with debiasing needed definitely for LGBTQs. So the best model is definitely, as of now, SFT with GPT OSS and combined prompts. If we look at all this holistically, we have done five approaches overall with GPT OSS and GPT-5, with SFT and two IFT each for GPT OSS and GPT-5. The GPT OSS 20B model fine-tuned with LoRa has achieved the highest F1 score of 0.669, with a recall of 0.787 and robust accuracy, making it the top performer for hate speech detection across demographics. If supervised fine tuning is not an option, then the V5 implicit example strategy for GPT OSS 120B is also a strong performer, which an F1 of 0.655 and a recall of 0.701. But it has showed higher false positive rates for LGBTQ content. GPT-5 combined prompt with a F1 of 0.604 is also good. It has got exceptional precision, though its recall and fairness for like bias groups is lagging behind. So primarily baseline approaches. Based on our hypothesis, we can conclude that the baseline IFT approaches, while balanced, they consistently underperformed advanced strategies, especially when we look at group level fairness. So this highlights the that parameter efficient fine tuning and targeted prompt engineering are essential for both high performance and fairness in automated hate detection systems. Persona level FPR and FN are also critical for fairness auditing, and can mask systemic errors if they are not considered separately. Uh, the recommendation is definitely to go with supervised fine tuning with LoRa, and it is recommended for deployment. However, bias monitoring and targeted mitigation, especially for LGBTQ content, is recommended. This is basically the overall recommendation of this research. Now, we will spend some time to look at the conclusions more holistically. So this research had got multiple phases, starting with the research literature review. And the literature review clearly revealed that there is a gap between traditional and classical machine learning systems. And more recent approaches have tried to remove these gaps by incorporating persona as well as policy methods in isolation, but have not achieved greater consistency. So the review highlighted that fully integrated persona and policy signals in a unified LLM framework is definitely lacking, and the standardized evaluation methodologies for those systems are not defined. So, to address these gaps, we have done this research. We selected hate explain and toxygen as we discussed earlier, and created a unified data set which was representative of both the implicit as well as the persona hate. And this data set was systematically cleaned and normalized, and used as a part of this study. The final unified dataset has 5,000 samples with balanced representation across both sources, and this could be used for further research. After the data preparation, we did an EDA, and the EDA confirmed that the quality and demographic balance of the unified datasets was present, and there was strong coverage of key groups like LGBTQ and Middle East. And The average text length was also around 108 characters, which ensures that it was effective and efficient for model input sizing and downstream evaluation. The data was partitioned into test sets. We wrote a modular prompt validation framework, which was developed to systematically test both the baseline as well as the combined strategies. And five principal strategies were tested, um, and multiple combined strategies. Five principal strategies were tested, and they revealed that prompt compression with the use of implicit examples consistently yielded best results. Excessive verbosity and over-engineered prompts degraded the performance. The model training leveraged both open source GPT-OSS and GPT-5 models with advanced prompt engineering, as well as LoRa fine-tuning strategies. And GPT-OSS achieved solid performance with both combined strategies as well as supervised fine-tuning. GPT-5 combined from delivered excellent and strong precision numbers, but lagged in recall and fairness. The recommendation is to go with supervised fine tuning for LoRa on GPT 2020B, which has got the overall best performance. Uh, as a part of this study, we have open source the entire frameworks as well as the unified dataset, which can then be used for further research. And these details are available on GitHub. Finally, we will come to recommendations. While this research established a robust framework for persona and policy-based hate speech detection systems, there are several important directions that remain for future work. Uh, this ca- this starts with further fine-tuning and additional parameters that we can encode, and deeper modules that we can write within GPT-OSS, which could further improve the recall and fairness. Benchmarking the unified framework against other state-of-the-art models is another direction which we could go, which will help access the generalizability and robustness. The persona taxonomy can include a wider range of demographics and intersectional identities, such as we can include age, disability, regional dialect, which will allow for more granular fairness, and it will reflect the actual diversity of online communities. We could also take real human in the loop feedback. Uh, Lastly, comparative, we could deploy these for like commercial social media platforms and adapt it for multilingual and multimodal hate speech to extend its utility. These will ensure that this research remains effective and becomes more ethical across more diverse digital environments. That's all we had. In summary, the hypothesis that we started with initially has been validated. I want to thank all of you for participating in my thesis defense. I appreciate your time and I'm grateful for all the attention and happy to take any feedback and questions. Thank you.